5.1 Polynomial Functions. This has got a lot of vocabulary and different things. It's not a difficult section, but it's just got a lot of little things that you got to remember when they're referring to certain things. You've got to know what those words are. Some of the words we're going to be talking about are intervals, decreasing and increasing, in behavior, domain and range, and degree. We've talked a little bit about in behavior and things before, and of course domain and range we've talked about too, but this is going into a little bit more detail. So some important vocabulary you need to know is the degree of the polynomial. Well, let's first talk about polynomial. Polynomial means anything that is more than one, well, it could be even one term. It could be a term of 5x to the fourth power, which is a monomial, or you could have a term which is 3x squared plus 3, which is a binomial. We worked with x squared plus x plus 3. Those kind of things are trinomials. Any of those are classified under polynomials. And the degree of the polynomial is the highest degree of x in that particular polynomial. And that is the degree for the whole polynomial. The degree classifies the polynomial, and it can be used to describe how it appears. So that's very important in the description of the graphs, which is what we're going to be doing in this section. The leading coefficient is the coefficient of the term with the greatest degree. Now, when you have these polynomials, you'll need to put them in standard form, okay? For instance, if it's not in descending order by the variable, by the x, you need to put it that way. Alright, so this is 5x to the fourth minus 3x squared plus 3. So the leading coefficient is going to be the one term that has the greatest degree. The greatest degree in this particular instance would be the 5x to the fourth power. So the leading coefficient would be the 5, the number in front of the variable. So that would be 5. Let me change my color over here. I think it'd be easier to see. Whoops, that still didn't change it. Alright, so in behavior is going to describe the graph's ends. Depending on the leading coefficient, if it's positive or negative, it affects the end behavior. And if the degree of the polynomial is positive or negative, affects the the end behavior of the polynomial. And we'll talk about those with plenty of examples coming up. And then the turning points are where the graph changes slope, whether it's positive or negative. Okay, so you're going to have graphs, and they're going to do this kind of thing. And turning points are where, like, this is going in the positive direction, and now it's going negative, and then it's going positive. So right here and right here is a turning point, and we'll be locating those. We'll also discuss some other names that you could find for these things. All right. All right, so a relative max or min is the highest or lowest location on the graph at a turning point, and that's going to be an ordered pair. Now, polynomials can have more than one maximum and more than one minimum depending on the degree of the polynomial. If it is an x squared, and that's the highest degree, the most it could have, max or min, would be 1. It's always 1 less than the degree. That is the most max and mins that it can have. So if it was an x to the fourth, at most it could have 3 maxes or mins, or a combination of both. Function intervals of increase and decrease, or also constant, can be presented in interval notation or in the form of an inequality. We are going to be working with these. We've worked with this before. Interval notation is something like this, where you have that infinity thing. Okay, interval is going to be going from this x to this x, or you could also see it listed as this greater than x greater than 2. Something like that. Okay, the interval between x is between infinity, this should be a negative infinity. Negative infinity to 2, okay? So it could be x is between negative infinity to 2, or it could be written this way, x is between negative infinity and 2. And what that is going to do is just describe whether the graph between these points, these x's, is it going up or down or constant. All right, so let's look at some graphs of these functions. F of x is equal to a. That's going to be similar to f of x is equal to 3, or y is equal to 3. Okay, the degree is going to be 0. Okay, and it is a constant. It does not change its slope or anything like that. Then the first degree is going to be in this kind of format, and the x in this situation has a degree of 1. So that's why it is a line, okay? It doesn't have any turns or anything like that. No max or min because it's just a line. All right? So that is a first degree. All right, so let's look at some more graphs. Well, yes, some more graphs. Second degree quadratic. This says ax squared plus bx plus c. And this is a quadratic term. Quadratic is anything that's x squared. Okay, so you need to know this word quadratic goes with the x squared. And it is a second degree because the little degree right here, the highest x value degree is a 2. And notice how this goes up. We've talked about this as a parabola. Okay, now because this is a positive ax squared, it's going up. Now, when we're going to be talking about in behavior, you'll notice that if it has an even exponent, that means that both ends are going to go in the same direction. And if it's positive and it's an even index, then it's going to go up. Or if it's a negative ax squared, then that would mean it would go down, but the ends would still go in the same direction. All right, third degree we talked about is cubic, and this is a ax cubed plus bx squared plus cx plus d, where the highest degree is a 3. That's why it's a third degree, and it's cubic. That's the name of those. You'll need to know that word, cubic. And it looks like this. It could be this way, or it could be drawn the other direction. But because this is a positive coefficient, if it's a positive coefficient, then that means that it is going to be going from down to up. Kind of like if you were to stretch this line out straight, it would be a positive slope. Okay, so therefore if it was a negative coefficient, it would zigzag this way, and if you were to stretch that line, it would be look like a negative slope. So that's the easiest way I can explain it for you to understand. It's going this way in the positive direction because it's a positive coefficient. It would go the opposite direction if it was negative. Now notice it's an odd degree, okay? Odd degrees mean they're going to have one end going one way and one end going the other, okay? Opposite directions. So you can tell based on the coefficient and the degree how the graph starts. Over here we've got a fourth degree quartic. That's a new word probably for you, quartic. You know what that is. Fourth degree, because the highest degree of this particular polynomial is a 4. And you'll notice because it is an even index that in behavior will go in the same direction whether it's positive or negative. Okay, but this one should This one's got a mistake on it because this one is going in the negative direction. There should be a negative right here. Okay, negative ax to the fourth power. This is a negative quartic. Had it been positive, it would look like a W. All right, and you'll notice that it's just added a bump. Every time we add a degree, it just kind of makes a turn. So this is the first one, and then it took a turn. Now we've got kind of two bumps put together, two polynomials, if you will. Excuse me, two parabolas, if you will. So notice that it is going in the same direction, and it's going in the negative direction. Okay, that's what this picture does. And then the fifth degree, if you were to write this, the highest degree of the x's would be x to the fifth. It would be positive because it is going in a positive thing. If you were to stretch that out this way, it would be going in the positive direction. And then you can notice how it has an extra little turn to it from this. So every time it adds a degree, it makes a little turn. Okay, fifth degree. And these are called quintic. Okay, quintic. That's a fifth degree. Right, so notice the end behaviors, if it's an odd degree, will go opposite directions. If it's an even degree, the end behavior of the graphs, these right here where it's going, keeps on going continuously, will be in the same direction. All right, find the degree of each of these. So we're looking at this one. Okay, let's talk about this. It is an S. It's got one parabola and then take a turn. So that would have to be a degree of 3. All right, now, notice it is going this way. If you were to stretch it out, it would be in the negative direction. So this would be a negative cubic polynomial. Okay, the end behaviors were going opposite directions because of the cube right here. And it's going backwards because it's negative. All right, look at number 2. It's a W. Okay, that means it's got one parabola and one parabola. The end behavior is going in the same direction, both going up. So this one would have to be a positive x to the fourth, which would be a quartic. All right, and this one over here is got one bump, two bumps, so that's 4 plus a turn. So this one's going to be a quintic. That would be an x to the fifth degree. And this one is going, reading left to right, this one's going up. So left to right, going up, that would mean it would be positive. Left to right here, it's going down, that's why it's negative. And then the last one over here is going left to right. We're reading it and it's going both down. So this is going to be a negative something or other. And it's got one bump, two bumps, and both going in the same direction. So it has to be x to the fourth, which is again quartic. Okay, notice it's the inverse direction of the one above it. It makes a W sort of, and it makes an M if it's upside down. All right? All right, now let's talk about the end behavior, which we did just a few minutes ago. End behavior functions with an even degree. Both of the ends either go up or they go down. And when A is positive, they go up, and when A is negative, they go down. So for instance, this is x to the fourth. That's a fourth degree. Quartic. Ooh, can't write. Quartic. And there, it's positive, it's going up. Okay, this is an even index. So both ends are going in the same direction, but this one is going to be going down. All right, and this end behavior is going left to right, and it is going up. It's positive, and it's a third degree, so that is cubic. This is quadratic. Be careful with that one. It gets people every time. Quadratic, quartic, and quintic are all real similar, so be careful with those. And this one is also cubic, one parabola and a turn. and it's going from left to right, it's going down in a negative fashion. Okay, so if the degree is odd, it's going to be opposite directions on the in behavior, and depending on if the coefficient is positive or negative is which way it's going. Determine the end behavior for each one of these. So it's going opposite directions, okay, opposite direction. So that must mean it is an odd degree. So that's going to be, let's see, 1 and a turn. So that's going to be cubed. So that's a cubic. And this one is going left to right, it's going down. So that's going to be a negative cubic. All right, number 2, that is both behaviors going in the same direction. So it must be even. There's one parabola and one more. That's going to be a quartic. And it's positive because both of them are going up. This one now is reading left to right, and we're going up, so it's going to be positive. I went 1 bump, 2 bumps, and then a turn. So that's to the 5th power, positive, and that's 20. And then this one is going both in the opposite direction, both in the same direction, but it's in a negative way. So this is going to be 1 bump, 2 bumps, that's quartic, but it's going to be negative. And it's going in the same direction because it is an even index. Right, turning points. When a graph turns and goes in another direction, the slope, in other words, changes its sign. It goes from positive to negative, negative to positive. That is called a turning point. It is the place where we've been finding the max and mins before. But the turning point is that actual location where it changes the sign. So for instance, this part right here is positive, but then it goes negative in the slope direction, and then it goes positive again. So how many turning points are there in this graph? Well, there's 1, 2. Where are they located? Well, that's going to be this point right here, which is 0, 1, 2, 3, 4, 5. 0, 5. And then again at 2, 1. Okay? So those are the 2 turning points. Now, turning points are very, very simple. Now, the one thing that people will get confused with, and it's really not difficult at all, but it's just a different way of looking at a graph. It's talking about intervals where x is and y is increasing. All right, so what you need to make sure you know is on the x-axis, this is going towards positive infinity. This side's going towards negative infinity. On the y-axis, this is going towards positive infinity, and this is going towards negative infinity. Okay? So it says on what intervals for x is y increasing. So in other words, where is it going up on the y? Okay? From here to here, from negative infinity to this x right here. Okay? That's at -1. From here, because it's going on forever, to here, this is decreasing. Okay, so that would say, this one says on what interval for x is y decreasing. All right, so that's going from negative infinity to the x value of -1. Excuse me. All right, that's where it's going down. From -1 to 1, it's going up. So I'm going to put -1 to 1 is going up. You notice I'm just talking about x values. And from the 1 to negative infinity, it's going down. Okay, so from here to here, 1 to negative infinity, it's going down. So positive, actually, it's going to be 1 to positive infinity because it's asking you about your x. So it says, on what intervals for x is y decreasing? So we're just talking about the x, and this is going from this x to positive infinity. So this one's going to be decreasing from 1 to positive infinity. These are x values, only x's. Okay, these are x's. But it's asking you what's happening to the graph between those x values. Between negative infinity and 1, negative infinity and negative 1, the graph is going down on the y. Between negative 1 and 1, the graph is going up on the y. And between 1 and positive infinity, the graph is going down again. Now, you can see this written like this, negative 1, x, x, and 1. X is between, this is the way you want to read it, x is between negative 1 and 1. This one would be negative infinity, x, negative 1. This one would be 1, x, and positive infinity. So it could be written this way or this way. You have to be familiar with both. They're only talking about x values. That's why the x is in the middle of this one. So x is between 1 and positive infinity. That's when y is decreasing. You have to be able to interpret your graph and what you've written down. And the more practice we get with these, the better off you'll be. So on this one, it says, on what intervals for x is y increasing? Okay, so remember we have, let me change this. We have negative infinity over on this end, positive infinity over here, positive infinity here, and negative infinity on my y's there. Okay, so it says on what interval for x is y increasing? So you want to look and see it's going from left to right, so you're going from this point right here to this point right here, it's going up. So that would be increasing. So that's going to be at negative 1 to 0, or written negative 1x 0. Okay? And then it is also going up from this point up here. So that's at 2. I'll write it down here. This one is from 2 to infinity. And that would be 2 to infinity. Okay? Either way, it's going up from that point. Okay? Between 2 and infinity, the y will be increasing, and from negative 1 to 0, the y will be increasing. So that means that from 0 to 2, or 0 is between x and 2, between 0 and 2, that would be decreasing right here. So remember, with intervals, you're only talking about writing the x values, but then they're asking you what's happening on the graph with the y. All right, so what is the minimum degree of this function? Well, you should know by now it's got one parabola and then a turn, so this is a third degree. That would be cubic. This one's going left to right, so it's going to be a negative x whatever, x to the third power. Let's write that better. Negative x to the third power. It's a degree of 3. Describe the end behavior. Opposite directions. And because it's negative, it's going down, then up. Okay. All right, how many turning points are there? There's one right here and one right here. That's where it changes the slope. There are 2. And what are they? That's at 1, 2, 3, negative 3, 0, and at 0, 1, 2, 3, 4. Okay, those are your turning points. And on what interval for x is y increasing and decreasing? All right, so when we're talking about intervals, we're only talking about x values. So this is negative infinity, positive infinity, positive infinity, negative infinity. So from negative infinity to 1, 2, 3, negative infinity to negative 3, we are decreasing. From 0 to positive infinity, we are also decreasing. And from negative 3 to 0, we are increasing. Okay? So these just look, what is your x value right here to what is your x value right here? Negative 3 to 0. Okay? All right, so we want to determine the increasing, decreasing, and the constants of this particular graph. Okay, so it's got all sorts of stuff going on in here. Now, if we needed to, we would put negative infinity, positive infinity, positive infinity, negative infinity on our graph. And we're going to talk about the decreasing ones first. All right, so it's going down until we get to 1, 2, 3, 4, negative 5. So down to negative 5, so that's going to be negative infinity such that x, negative 5. Okay? I'll write it a different way this time. And then it's also decreasing going from this point down. So that's going to be from 1 until 1 to 4. Okay? 1, x, 4. And then that's the only place it's decreasing. Okay? And then increasing would be, it's going up from here to here, so that's at negative 5 to negative 3. And it's also going up from negative 1 to 1, from here to here. And it's going up from 4 to 5. Okay, so you can see it written this way or this way. You would write these to be negative 5 less x less negative 3, negative 1 less x less 1, 4 less x less 5. And it would be constant between this part and this part. In other words, the slope is 0. So this would be between negative 3 and negative 1. Constant. And also again over here add 2, 4, 5 to infinity would be constant. Okay? Think of it if you had a little, I don't know, bug or a person walking. You know, if you have to think about a person walking. Are they going down from here to here, or are they going up? See, and if you think of it that way, it'll help you a whole lot. Put a little person over here, is it going down or up? All right, so that's determining the increase, decrease, and the constant intervals. And that is all we have in this section, and that was plenty enough. We will work more on this in class. Come see me, and we'll do lots of practice problems on this. See you in class.